Welcome to week 10, chapter 5 of the hands-on database textbook. I'm here in Blackboard in the weekly assignments area and in week 10. I'm going to click on the lecture folder. This chapter is a little different. Normally I would talk about the slides here, maybe do a demo in Access that I did the first 8 weeks. But I'm not going to look at the slides for this chapter. My suggestion is to read and maybe listen to the videos that I'm going to make for these other items you see here in the lecture folder. The functional dependency example, the normalization rules of one and rules of one summary, and this normalization tutorial. I'm going to make videos for all of these. This chapter, chapter 5, talks about normalization. It's one of the most difficult topics of this particular course in relational database design because it's just theoretical in nature, and it's some hard concepts to understand. That's why it's going to take a while to get through this part of the chapter. So I'm going to start with this functional dependency example. It's a PDF file. I'm just going to click on it. And the reason I'm doing this is because when you get into these normalization steps, they start using terms like determinants, functionally dependent. Those terms right there are something you need to understand before you can continue. In this first example, A, B, C, D, they represent fields in a table. Or you can think of them as attributes of an entity that you're trying to design. However you want to think about them. I think about them as fields. Anyway, what this says here, this notation says A functionally determines B, C, and D. A then is the determinant. B, C, and D are functionally dependent on A. So that's the way that reads, that notation. What it means is for any single value that you can come up with for field A, you can determine a single value for B, C, and D. Now, like I said, this terminology sounds funny, but when you think about it, A really is going to become the primary key of this table once we implement it in a physically create it in a database. So you can think of this, maybe this is the, say, an employee number, and this is an employee's first name, last name, and the department that they're in. So if you get the employee's employee number, you can determine a single value for B, a single first name, a single last name, and a single department. Going forward a little bit, I know we didn't talk about the normal forms yet in normalization, but if C determined D up in this particular collection of fields, then that would break the third normal form, which says a field cannot be functionally dependent upon a non-key field, which C is not it's not a key, it's not over here on the left-hand side, can't functionally determine all of the fields. This second example, very similar. I'll go through this a little quicker. But A and B together are the determinant. C and D are dependent on A and B. That means for any single value that you put in A and B together, you could determine a single value for C and a single value for D. In this case, A and B would be what's called a concatenated primary key for the table. We haven't done a whole lot with concatenated primary keys yet, but we'll do that in this normalization step. It's really just where two fields together are the primary key. I know almost all the examples that we've seen up to this point, a single field is the primary key, but it is possible for a table to have a concatenated primary key. If the case came about where B determined D, if this was another functional dependency in this collection of fields, then that would break the second normal form, which says a field cannot be dependent on only a part of the primary key. And B is just a part of the primary key. You may have to read a little bit about what a concatenated primary key is, but it's where two fields together, concatenated together, the values are the primary key. Okay, the rest of this document is an example, and I really suggest you just look through it. It's not very long here, and then you'll be ready. Hopefully, this little video on determinants and functional dependencies might be a help for you when we start talking about normalization, which I'll do next in the next video.